Again, to the lesson of chapter vectors, we are in lesson 9.2, Introduction to Vector Algebra. So in this lesson, we will see how we're gonna do the operations with vectors. The first part in this lesson is the vectors and coordinates. So it's a little bit like the language of the vectors and how do we call each term of the vectors. So if I have a vector OP, I can write it, you can see it in some Lebanese and American book this way, xi, and above the I, there is a sign vector. Guys, normally in all the American and Lebanese book, you will see the sign vectors. But you will notice that in the IB book, sometimes you will see that they represent the vector A like this, without the sign here. So this just you can see it in the IB book. It doesn't mean that it's not a vector. So in the American and Lebanese book, you will see, for example, the coordinates xi plus yj with the vector above the letters I and j. But in the IB book, you will see it like this, xi plus yj, but it's still the same meaning. It means that the value that's here, it's the x of the vector, and this is y. What does it mean, x? We say x, it's an abscissa or the horizontal component, because this is the x-axis, so it's like it's in the direction of the horizon, so we call it the horizontal component. Y represent the ordinate or the vertical component, because this is y. And then x and y, we call them together the coordinates of the vector. Now, if two vectors are equal, it means they have the same x and the same y. For example, I can give you this example. Given the vectors u, 2x, and 4, and the vector v, 4, 3y, I can ask you to find the value of x and y so that the two vectors are equal. When I say u is equal to v, it means x of u is equal to x of v. What does mean x? Be careful. When I say x, it means not this x. It means the abscissa of u is equal to abscissa of v. So 2x is equal to 4. I can solve it to find x is 2. And it means the ordinate or the vertical component are equal. So 4 is equal to 3y and gives me y is equal to 4 over 3. Now, if I'm doing more operations with the vectors, for example, here I have two vectors u and v, and I'm asking you to find the coordinate of the vector w that represent 2u plus 3v. So I can do those operations with the vectors. We can call that multiplying by a scalar. So when I say 2u, it means I'm multiplying u by a scalar or by a number. So, and this relation 2u plus 3v, it's called the linear combination. So here, this one, we call it a linear. I'm just giving you the technical words. If you saw it in the book, so you understand what this means. This one, we call it linear combination of two vectors. When I say 2u, it means I'm multiplying this vector by a scalar, by a real number. Okay? So it means to find the abscissa of w, I need to multiply x of u by 2 plus the x of v by 3, and then we add them together. So it will be 2 times 2 plus 3 times 4. It's 4 plus 12, so it's 16. And I need to multiply also the y the same. 2 times 3 is 6 plus 3 times minus 2, so minus 6, so it gives me 0. It means the coordinates of the vector w are 16 and 0. So be careful. It's a notation. We know it from preceding chapters, from chapter 6, we know that how to find the coordinates of the vector. So if I have 2 points A and B, to find its coordinates of the vector AB, so it's xB minus xa. So all the time we start with this point, minus yb minus ya. Guys, all those rules also work for the vectors in 3D. You'll see it now in the example. If I have x, y, and z, also it's the same formula. So exactly the same step, but you're gonna do the z as extra. Now, part two, it's magnitude of a vector. Also, what does mean the word magnitude? Magnitude, it means length. It means I'm using the distance formula between 2 points. So sometimes I can ask you to find the magnitude of a vector, but you have just the beginning and the ending of the vector, the points that form the vector, and sometimes I can give you directly the vector to find its magnitude. So for example, here in example 1, if I have the vector u to 4, what is its magnitude? You can see it this way. Also, you can see this notation, and sometimes in the Lebanese and American books with 2 bars. But this one, it means absolute value, and you know that absolute value gives me a positive answer. And the absolute value, it's a distance, so that's why we write it this way. Also, you can see it this way. If you saw this notation, also it's the same thing. So it's x squared plus y squared. So we add it's radical of the square of the coordinates. So it is 4 plus 16, it's radical 20 units. I can simplify it if I want. Radical 20, I know that it's 5 times 4, so I can write it also 2 radical 5. Now for the second example here, if you see guys, I just have the starting and the ending point of the vector. So what is the magnitude of the vector AB? So first of all, I need to find the coordinates of the vector. So those bars here, this one like the absolute value means the magnitude of, I'm trying to find the coordinates, x of b minus x of a, y of b minus y of a. So this is the magnitude of 2 of the coordinates. So it's radical x squared plus y squared, 2 squared plus 2 squared. It's 4 plus 4 radical 8. It's 2 radical 2 units. Or I can do it like this. This formula, you see it in the Lebanese and in the American books. It will give you the same answer, but it's another way to write it. Another example, for example, how can I do the application of the magnitude in another exercise? For example, I can give you 3 points and I can ask you to show that the triangle is right. For the moment, you don't know how to prove right triangle using the vector. In the next chapter, we will see it. So I need to use the lengths. So I need to find the lengths of AB, AC, and BC. But here, if you notice that you have Z, the same formula. So it's here it's x of b minus x of a, y of b minus y of a, z of b minus z of a. So I have the coordinate will be 0 minus 1, 4 minus minus 1, so it's 4 plus 1, and 1 minus minus 2, it's 1 plus 2. The magnitude of those coordinates, so it's radical minus 1 squared plus 5 squared plus 3 squared, and I have the answer radical 35. I can write unit. Same formula for AC, units. And for BC, I directly wrote it this way, so I will show you directly the final answer. Now you have the 3 sides. How are we going to prove a right triangle? We know that from grade 9 we use Pythagoras. So you look at the longest sides. If it's a right triangle, which side would be the hypotenuse? It's the longest side. So I square the longest side. Then I add and square the other 2 sides. If they are equal, it means it's a right triangle. So longest side is radical 35. So radical 35 squared gives me 35. The other 2 sides gives me also 35. What does it mean? They are equal, therefore it's a right triangle. And how do you know at which point? So if the hypotenuse is AB, it means if this is the hypotenuse AB, it means the 90 degree is opposite to the longest side. So what's gonna be the vertex? It's C. So it's a right triangle at C. We will see later on in the next chapter, we're gonna do the scalar product. We have another method also to prove a right triangle. Now the last part is the unit vector. What does mean unit vector? When I say unit vector, it means the magnitude or the length, also I can write it this way, of the vector is 1. So when I say unit vector having same direction, it means when they say same direction, also they mean that by the same sense. In the American books, you see direction, sense, and magnitude, and the Lebanese book too. In the IB books, the direction they sometimes combine it with the sense. It means I have the same direction and the same sense. So I need to go to the on the to the from the same side, left to right, for example. So to find the unit vector having same direction of a given vector, I have 2 formulas, one for 2D, one for the 3D. So it's 1 over the magnitude or the length of the vector times its coordinates. I will give you an example, and from the example you will understand, guys, this formula. Okay, you will see why it's 1 over the magnitude. Okay, I'm just fixing it with the same color. So let's move to the example. I just have still 2 examples and that's it. So find the unit vector that has same direction. So here when they mention direction, it means the same the sense as W2I plus 3J minus 6K. So this is the notation. They put it like this. So this is the unit vector of W. It's 1 over the magnitude. So it's radical 2 squared plus 3 squared minus 6 squared times the vector 2I plus 3J minus 6K. So the magnitude will be 1 over radical 49. It means 1 over 7. And then I multiply it. So it will be 2 over 7I plus 3 over 7J minus 6 over 7K. Guys, why we did that? If you try to calculate the length of this vector here, it will be this is squared plus this is squared plus this is squared, the radical. So when I do radical 2 squared, it's 4 plus minus 3 squared, it's 9, plus 36, over 7 squared, it's 49. It's equal, look at it, guys. It's radical 49 over 49. That's why it gives me 1. So that's why I divide by the magnitude of the vector to have the magnitude over, to have it over each other, and we'll have the ratio or the answer 1. That's why we have this formula. Now for the last example in this lesson, now here I said, find all the vectors parallel to A is equal to I minus J plus 2K. So when I say parallel, it means I have the same direction. And that have a magnitude of 5. So here I want the vector parallel to A having the same magnitude of 5. So it means the magnitude of this vector, I will name the new vector B. So its magnitude should be 5. Guys, when I say collinear vectors or parallel vectors, it means I can write a relation. For example, B is equal to lambda or alpha A. So we know this from the preceding chapter. You see also they are parallel or collinear vectors. So we know that it means that B is equal a constant times the other vector. It could be B is equal to 2A, 3A, but here I want the magnitude of B is to be equal to 5. So my first objective is to find by which constant I need to multiply A together. That's it. A, I have it. All what I need to find the vector B. To get this vector, I need to multiply A by any constant to give me the collinear vector to it. But my first objective is to find this constant. I have a property that this new vector should have a magnitude of 5. So magnitude of B is equal, should be magnitude of lambda times magnitude of A. So my objective is to find this constant. So it's magnitude of B over magnitude of A. So it's 5 over radical 9, so it's 5 over 3. But this one gives me the absolute value of lambda. So this constant could be plus or minus, because even if you multiply it by plus or by minus, the magnitude in the end it's positive. And then all what I need to do if I multiply the given vector A by 5 over 3 or by minus 5 over 3. In two cases, if I try to find the magnitude, it means if I try to find radical 10 over 3 squared plus this one squared plus this one squared, going to give me the answer 5, either this one. So here I have two vectors. They are, so this vector, I can write it B1 is equal 5 over 3A. So those are collinear vectors. They are parallel. And this one, it means B2 is equal minus 5 over 3, sorry, A. So it means here they have both the same direction. Here one it's like this, one it's like this, but in the end they have the same length. They have the same magnitude. Okay, that's it for this lesson. So if you didn't get it, review it again and we'll do more application in the class.